This video we're going to talk about the sum and difference identities in trigonometry, and what these are formulas that help you figure out angles that you might not necessarily know. So given the unit circle, we know the values at 60 degrees, 45 degrees, and 30 degrees. For 60, sine equals square root of 3 over 2, and cosine equals 1/2. At 45, sine and cosine are equal to square root of 2 over 2. And at 30 degrees, sine is equal to 1/2 and cosine is equal to square root of 3 over 2. So these are the ones that we know, and if we drew lines in other quadrants, we could figure out what they are by just changing the signage of the values we know. But for example, say I wanted you to find the value of 15 degrees. So we're looking for this angle. Using the sum and difference formulas, you can basically combine the stuff you know in different ways. So to find 15, we could take 45 degrees minus 30. And so say I wanted you to find the cosine of that. You just do cosine of this, and then you plug it into the formula I'm gonna show you. Same thing for, say, 75 degrees. 75 equals 30 degrees plus 45 degrees. So if you wanted to find the sine of 75, you would do something like sine of 30 degrees plus 45 degrees and then fill in the formula. So if we move over the formulas, I didn't want to take the time to write them out while recording, so I wrote them all out here. We have sine of alpha plus beta equals sine of alpha times cosine of beta plus cosine of alpha times sine of beta. Then we have sine of alpha minus beta is sine of alpha times cosine of beta minus cosine of alpha times sine of beta. Then we have cosine of alpha plus beta equals cosine of alpha times cosine of beta minus the sine of alpha times the sine of beta. Cosine of alpha minus beta equals cosine of alpha times cosine of beta plus sine of alpha times the sine of beta. And then we get into the tangent functions. So for tangent of alpha plus beta, we have tangent of alpha plus tangent of beta over 1 minus the tangent of alpha times the tangent of beta. And then finally, there is tangent of alpha minus beta, which is tangent of alpha minus the tangent of beta over 1 plus tangent of alpha tangent of beta. Now that we know what the sum and difference formulas are, we're going to run through some practice problems. So to start off, we have the sine of 45 degrees minus 30 degrees. So this is actually equal to the sine of 15 degrees, but you wouldn't really know that just by looking at it. So this is where our formulas come in. We're going to start off with the sine of alpha minus beta equals the sine of alpha times cosine of beta minus the cosine of alpha times the sine of beta. So we're going to assign our variables. So this is alpha and this is beta. And then on the side over here, we're going to figure out what the sine and cosine of each of these is. So sine of 45 degrees we know is square root of 2 over 2. Cosine of 45 degrees is equal to square root of 2 over 2. Then we have the sine of 30 degrees, which is equal to 1/2. And then the cosine of 30 degrees, which is equal to square root of 3 over 2. So now, if we fill in our variables here, 45 degrees minus 30 degrees equals sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. Now we have all the variables we need to plug in and finish our equation. So this is going to be square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. So if we do out this math, we're going to get square root of 6 over 4 minus square root of 2 over 4. And that's going to equal square root of 2, square root of 6 minus the square root of 2 all over 4. And that is the value of sine of 45 minus 30. Sweet. Let's move on to the next one. Here we have cosine of 75. So they didn't separate it for us. And that's what we'll have to do next. So this is going to be cosine of 30 degrees plus 45 degrees. Our equation for cosine in sum is cosine of alpha plus beta equals the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. So if we assign our variables alpha and beta, we can rewrite this as cosine of 30 plus 45 equals cosine of 30 cosine of 45 minus the sine of 30 times the sine of 45. And what we'll need to do, I'm going to erase this over here, is figure out the sine and cosine variables for each of these angles. So sine of, say, 30 is equal to 1/2. Cosine of 30 is equal to square root of 3 over 2. Sine of 45 equal to square root of 2 over 2. And cosine of 45 also equal to square root of 2 over 2. So let's plug them in. This is square root of 3 over 2 times square root of 2 over 2 minus 1/2 times square root of 2 over 2. This is going to be square root of 6 over 4 minus square root of 2 over 4. And it looks a lot like the one before, just a little bit different. Actually, it's the same thing. So cool. And that is cosine of 75 degrees. All right, and then for the final one, we have a difference of angles. So we're going to write out our difference formula for sine. Sine of alpha minus beta equals the sine of alpha times the cosine of beta minus cosine alpha sine of beta. Then we're going to get the sine of 135, which is going to be square root of 2 over 2. The cosine of 135 is going to be negative square root of 2 over 2. Sine of 120 is equal to square root of 3 over 2. And the cosine of 120 is equal to negative 1/2. So plugging these in, actually let's run through sine of 135 times the cosine of 135 minus, did that wrong, cosine of 120 minus the cosine of 135 times the sine of 120. This is going to be square root of 2 over 2 times negative 1/2 minus negative square root of 2 over 2 times square root of 3 over 2. So on this side we have negative square root of 2 over 4 plus, so these are going to become positives, square root of 6 over 4. So we're going to have square root of 6 minus the square root of 2 over 4 equals the sine of 15 degrees. So you've been played, you just solved the same problem 3 times.